So in the previous class, we have discussed what is force and what are the characteristics of the force. So force is defined as an agency which tends to change the state of rest or motion of the body. So it tends to produce motion when the body is at rest, or it tends to check the motion when it is already in motion, or tends to change the motion of the body, right? So to define the force completely, we must know its 4 characteristics. So what are the characteristics of the force? These characteristics are also known as specifications of the force, right? So one is its magnitude. It defines the amount of force. Generally, we measure the force in Newton. Second one is direction. So direction of the force is defined as the direction of straight line in which the force tends to move the body. And that direction, that straight line is also known as line of action of the force. So simply the direction of force is nothing but the direction of line of action of the force. And what is the third characteristic? Point of application. So point of application of force is defined as it is the point at which the force is assumed to be concentrated. So force will never act at a point. But if the area of contact is small, we are assuming that the force is acting at a point. And the fourth characteristic is sense. It indicates whether the force is trying to push the body or pulling the body. So it is indicated by the arrow head. So in order to define the force completely, you must know these 4 characteristics. Okay. Then we have seen the force systems, different types of force systems. So what are the types of force systems? We have learned in engineering, basically there are 4 types of force systems. Coplanar force system and a non-coplanar force system. Means if all the lines of action of the forces are in the same plane, if all the forces are acting in the same plane, then that system is known as coplanar force system. If not, non-coplanar force system, right? Then we have concurrent force system and a non-concurrent force system. If the lines of action of all forces are passing through a common point, then it is known as concurrent force system. If not, non-concurrent force system. Then we have parallel force system. If the lines of action of all forces are parallel to each other, it is parallel force system. If not, non-parallel force system. There are 2 types of parallel force system, like parallel force system and unlike parallel force system, right? So in like parallel force system, the lines of action are parallel to each other, but the sense is same. It is like parallel force system. In unlike, the lines of action are parallel to each other, but the sense is opposite. So it is unlike parallel force system. Then we have collinear force system and a non-collinear force system. If the lines of action of all forces are acting along the same line, then it is collinear force system. If not, non-collinear force system. Then again, we have the combination like coplanar concurrent force system, lying in the same plane, passing through a common point. Then coplanar parallel force system. Then non-coplanar concurrent, lying in different planes but passing through a common point, and so on. So we have different combinations. Okay. Then we have moment of force. So the effect of force on the body is twofold: to produce translation and to produce rotation. So the rotational effect, the turning effect produced by the force on the body is nothing but moment of force. So how do you calculate moment of force? By taking the product of the magnitude of force and the perpendicular distance from the line of action of the force to the point about which the moment is to be taken. And what is the sign convention which we are following for moment of force? If it is tending to rotate the body in anti-clockwise direction, we are treating it as positive. And if it is acting in clockwise direction, we will consider it as negative. And what is the unit of moment of force? It is force into distance. So Newton meter, SI unit. Then we have also discussed couple. So couple means pair. So two equal and opposite parallel forces are said to form a couple. So when the couple is acting on a body, let us consider this as a body. So there are two forces of magnitude P acting parallel to each other. So the lines of action are parallel to each other and they are acting in the opposite sense. Say the distance is D. Then the moment of this couple is the product of any one of the force into the perpendicular distance between the two. Again, the unit is Newton meter. So the effect of couple on the body is only to produce rotation. So by applying these two forces on the body tends to rotate in anti-clockwise direction. Okay. Now we will see what are the characteristics of couple. So this is very important concept. Characteristics of couple. Couple does not produce translation, but tends to rotate the body. Why it is so? This is because the resultant force of the couple is zero in any direction. As the resultant force is zero, there is no translation. But the resultant moment of the couple is not zero. Therefore, there is a rotation.
Sir, what is translation?
Translation means movement of the body from one place to the other. Means the position of center of gravity of the body is changing. Say the particle is having displacement. Then you can say that the particle is having translation. Suppose, say this is the G, is the center of gravity of the body. So when you apply the force on the body, and if the position of the body changes, so simply if there is a change in the position of center of gravity, so it is moving through this distance, then you can say that the body is having translation. If there is a change in the position of center of gravity of the body, then you can say that it is having translation. Suppose if this body having center of gravity G is rotating about point G only, so the entire body is rotating about point G. So is there any change in the position of G? No. Am I right? The position of G is not changing, and hence the body is not having translation. There is no translation, but the body is moving, it is rotating about point G. So you can say that this body is having rotation. Is it clear? So the effect of couple on the body is to produce only rotation. Why? Because the resultant moment of the couple is not zero. So it is having rotation. But if you find the resultant force of the couple, then you will find that it is 0. Hence, there is no translation. I told you the effect of force on the body is twofold: to produce translation and to produce rotation. So the force is responsible for translation and the moment of force is responsible for the rotation. As the resultant force is 0 for the couple, there is no translation, but there is a resultant moment. Therefore, the body undergoes rotation. So let us take this example. So on a body, two forces of magnitude 10 Newton are acting at A and B. So the lines of action are parallel to each other. So the distance between the lines of action of these forces is 2 meters. Now you can say that these two forces are forming a couple on the body because the magnitudes are equal, they are parallel in action, but sense is opposite. So two equal and opposite parallel forces are said to form a couple. Now let us find out the resultant force of this couple. So simply, what do you mean by the resultant? It is the net effect, combined effect. In fact, it is the combined effect, right? Means to find out the resultant force of all the forces, simply you have to take the algebraic sum of the forces. So this couple is having two forces. Now I will find out the algebraic sum of these two forces to get the resultant force. For that, I will select this x and y axis with respect to say A. So what is the resultant force? Algebraic sum of the forces. These two forces are acting in y direction. So I'm taking algebraic sum in y direction, summation Fy. So the first force, this 10 Newton, is acting downwards. As per our sign convention, if the force is acting downwards, we will take it as negative. And the second force is acting upwards, therefore it is positive. Hence, the resultant force, the algebraic sum is 0. Therefore, you can say that the body is not having translation. So, no translation. Is it clear? Now, let us find out the moment of these two forces. So, the resultant moment. So, let us take moments about point A. So whenever you want to find out the resultant moment, so you can take any point as the reference, right? Suppose if I take point A as the reference to find out the resultant moment, simply it is the algebraic sum of the moments of the forces acting on the body, right? So what is the moment of these 10 Newtons about point A? The line of action of this 10 Newton is passing through point A. So its moment is 0. Am I right? So it is 10 into 0. The perpendicular distance is 0. Whereas moment of this 10 Newton about point A, so it is 10 into perpendicular distance, 2 meters. So it is 10 into 2. And what is the sense of this force, sense of the moment of this 10 Newton force? It is acting in the anti-clockwise sense, right? About point A. So it is creating anti-clockwise sense. Therefore, it is plus 10 into 2. So it is 20 Newton meter anti-clockwise. So here, the resultant moment of this couple is not equal to 0. Therefore, it will produce rotation. Understood? So the couple will produce only rotation, but no translation. When you apply a force on the body, when you apply a couple on the body, then the body tends to rotate, not to translate. Understood? Then, moment of couple is always constant, irrespective of the point. Sir. Yes.
Sir, are the forces in couple always equal in magnitude?
Yes, then only we can say the couple. No? What is the definition of couple? Two equal and opposite parallel forces are said to form a couple. So, if the magnitudes of those two forces are equal, opposite, and parallel, then only we will call it as a couple. It means in a couple, the magnitude of forces always equal. Now, moment of the couple is always constant, irrespective of the point about which the moments are taken. See here, same example we are considering. So two 10 Newton forces are acting on a body in the opposite direction and they are parallel in action. 2 meters is the distance between the two lines of action of the forces. Now what is the moment of the couple? Simply it is the product of magnitude of any one of the force into the distance between the two. So it is 10 into 2, 20 Newton meter, and the sense of rotation is anti-clockwise. So the moment of the couple is 20 Newton meter anti-clockwise. Now I will consider the moment of these two forces about point A. In the previous slide we have seen this. We are taking moments about point A. So moment of this 10 Newton which is acting at A will be 0 because perpendicular distance is 0. Then moment of this 10 Newton which is acting at B about point A. So it is 10 into 2 and the sense is anti-clockwise. So again we are having 20 Newton meter anti-clockwise. Now I will take moment of the couple about point B. Now moment of this 10 Newton which is acting at B will be 0 because the line of action is passing through point B. And the moment of 10 Newton which is acting at point A about B will be 10 into 2, again 20. And what is the sense? It is creating anti-clockwise moment. Am I right? About point B, this 10 Newton, it is creating anti-clockwise rotation. So it is plus 10 into 2. Again, we have 20 Newton meter anti-clockwise. Now let us consider point C, midpoint at 1 meter distance from A or B. Now let us find out the resultant moment at point C. Now what is the moment of this 10 Newton which is acting at A about point C? So it is 10 into perpendicular distance is 1 meter, right? So it is 10 into 1. And what is the sense? It is anti-clockwise. Am I right? So this 10 Newton is tending to rotate about point C in anti-clockwise direction. So it is plus 10 into 1. Now what is the moment of this 10 Newton which is acting at B about point C? Again it is 10 into perpendicular distance between point C and 10 Newton. So it is 1 meter, right? So 10 into 1. But what is the sense of rotation about point C? Again it is anti-clockwise, right? It is creating anti-clockwise moment. Therefore plus 10 into 1. So the total it is 20 Newton meter anti-clockwise. Is it clear? So whether you take moments about point A or moments about point B or moments about point C, we are having 20 Newton meter anti-clockwise only. Let us consider some other point, say D, at a distance of say 3 meters from A. Now we will find out the resultant moment of these two forces about point D. So what is the moment of these 10 Newtons which is acting at A about point D? 10 into perpendicular distance is 3 meters. So 10 into 3. But what is the sense of rotation? This 10 Newton is tending to rotate in clockwise direction about point D. Right. So the clockwise moments are taken as minus. So it is minus 10 into 3. Now, what is moment of this 10 Newton which is acting at B about point D? So it is 10 into perpendicular distance from D to B, that is 3 plus 2, 5 meters. So it is 10 into 5. And what is the sense of rotation of this 10 Newton force about point D? Yes, anti-clockwise. So
Anti-clockwise.
Plus 10 into 5. So the net moment is again we have 20 Newton meter anti-clockwise. So the moment of the couple is always constant, irrespective of the point about which the moments are taken. So in a plane, you can consider any point. Let us consider this as point E. And if you take algebraic sum of the moments of these two 10 Newton forces about point E, you will find that it is 20 Newton meter anti-clockwise. Okay, so moment of couple is always constant. Then two couples are said to be equivalent if they have same magnitude and sense, irrespective of the forces constituting the couple. Take example. So here there are two different types of couples. This couple is formed by two 10 Newton forces, and here the couple is formed by two 5 Newton forces, right? So the distance between these two forces, say 2 meters, the distance between these two forces is 4 meters. Now what is the moment of this 10 Newton force couple? Simply it is 10 into 2, 20 Newton meter. And what is the sense of rotation? Anti-clockwise, right? Similarly, what is the moment of this couple in the second figure?
20 Newton meter.
Because of this anti-clockwise sense, the body is rotating in anti-clockwise. So here the magnitude is 5 into 4, again 20 Newton meter, and the sense is again anti-clockwise. So both the couples are having same magnitude, that is 20 Newton meter, and having same sense, that is anti-clockwise. Then I can say that these two couples are equivalent, means the effect of these two couples on the body is same, though the forces constituting the couple are different. Understood? So irrespective of the forces constituting the couple, if they have same magnitude and sense, you can say that these two couples are equivalent. So now what are the characteristics of couple? Couple will always produce rotation. There is no translation. Why it is so? The resultant force of the couple in any direction is 0. Therefore, no translation. But the resultant moment of the couple is not equal to 0. Therefore, there is a rotation. So the moment of couple is always constant, irrespective of the points about which the moments are taken. The moment of couple is always constant. And two couples are said to be equivalent if they have same magnitude and sense, irrespective of the forces constituting the couple. So any doubt? What is the basic difference between moment of force and moment of couple? Because the effect of moment of force on the body is to produce rotation only, and the effect of moment of the couple is also to produce rotation. But what is the difference? See, moment of force, it is the turning or rotational effect produced by the force on the body, whereas moment of couple is the rotational effect produced by the couple on the body. So here the effect remains same, but the difference is here moment of force is calculated by taking the product of force and the perpendicular distance d from the line of action of the force to point A, that is about which the moment is taken. Whereas the moment of couple is also calculated as with the product of force into distance. What is that distance? The distance between the two lines of action of the forces. So for a given force, the moment depends on the point about which the moment is to be taken. So the magnitude of moment depends on the point about which the moment is to be taken. As in case of couple, for a given couple, the moment is independent of the point about which the moments are taken. This we have seen in the previous example. So while taking resultant moment of these two forces about different points, we found that the moment of the couple remains constant. It is independent of the point about which it is taken. Whether you take moment about A, moment about B, or moment about C, moment about D, anywhere in the plane. So the moment of couple remains constant. So the basic difference is this only. Moment of force depends on the point about which moment is to be taken, whereas moment of couple is independent of the point about which the moments are taken. Then let us have a small quiz. A force can be defined completely by knowing which of the following characteristics, right? So magnitude, direction, point of application, as well as sense. So a force is defined as an external agent which tends to change the state of dash of the body, right?
Rest and motion.
Which tends to change the state of rest or motion of the body. The turning effect produced by the force on the body is known as the force, right? Then the moment of force about a point is calculated by taking the product of force and the product of force and the perpendicular distance between the line of action of the force and the point. It is not simply the distance between the force and the point. Perpendicular distance from the line of action of the force and the point. If the lines of action of all forces are acting along the same line, then the system is known as collinear force system. Very good. So the lines of action of all forces are acting along the same line. It is collinear force system. Now forces acting in the tripod stand is an example for what is the answer? Do you know what is tripod stand? So it is a stand having 3 legs. So the forces acting in the legs of the tripod is an example for
C.
Coplanar parallel force system. See, I will give you an idea how the tripod looks like. Suppose you have this X, Z plane, horizontal plane. You have this Y. These are the legs of the tripod. So you are applying some force on the tripod. Then these 3 legs are resisting this force, right?
Yes.
Now tell me what is the correct answer. You are saying option? Yes, which option?
D.
D. Please see here, non-coplanar parallel. So these are parallel. The lines of action of these forces are not parallel. No? See the arrowheads. These are all passing through this point. So all these 3 forces are forming a concurrent force system, but they are acting in different planes. Am I right? So it is non-coplanar concurrent force system. Understood?
Yes, sir.
Forces are acting in
Yes.
different planes, but passing through a common point. Now a couple is said to form by 2
So D.
D. Very good. 2 equal, opposite and parallel forces. Then effect of couple on the body is to produce rotation, right? Then which of the following is independent of the moment center?
B option.
Moment of couple, right? So it is independent of the moment center, whereas moment of force, it depends on the moment center, right? The moment of force P about point B. You please refer this figure.
Option number C, sir.
Option C, right? So here there are 2 ways of finding the moment. So we know that the moment is the product of force and the perpendicular distance from the line of action of the force to the point about which moment is to be taken. We are taking moment about point B, and this is the line of action of the force. So simply draw perpendicular distance, perpendicular from the line of action of the force. Say that is D. Now this 18 Newton force is making 60 degrees with respect to horizontal, right? So now moment about point B, it is the product of force, magnitude of force AT into perpendicular distance D. And what is the sense of rotation? It is anti-clockwise, right? If you see the rotation of this 80 Newton about point B, so it is rotating, it is having anti-clockwise sense. Now to find out D, if you consider this right angle triangle, say ABP sine 60, opposite side, that is D upon hypotenuse 5. So D is equal to 5 sine 60. So it is 4.3 meters. So now the moment about point B, it is anti-clockwise plus 80 into 4.3. So it is coming 346 approximately Newton meter anti-clockwise. Understood? So it is 346 Newton meter anti-clockwise. Sometimes it is difficult for us to find out the perpendicular distance. In such cases, you can resolve this force into two perpendicular components, horizontal and vertical. So this we are going to study in the second chapter, right? Resolution of force. So the horizontal component is 80 cos 60 and the vertical component is 80 sin 60. Now you have to take moment of this force about point B. Now if you take the algebraic sum of the moments of these two components, which is same as the moment of force by Berigna's theorem, that also we are going to learn. Don't worry at this moment of time. So those who know about these components, they can follow. So the moment of 80 cos 60 about point B is 0, right? Because the line of action of this force is passing through point B. So the moment of 80 cos 60 is 0. Plus the moment of 80 sin 60 about B. So it is forming anti-clockwise sense. So it is plus 80 sin 60 into perpendicular distance. What is the perpendicular distance from the line of action of force to B? 5 meters. 80 sin 60 is acting vertically. So this horizontal distance is perpendicular distance. So 80 sin 60 into 5 is nothing but 346 Newton meter anti-clockwise. So either by finding the perpendicular distance, you can calculate the moment, or if it is difficult for you to find out the perpendicular distance in some situations, you can resolve the force into components and using Berigna's theorem, you can find out the moment. Okay. Then the moment of force P in the same figure, figure 1, about point E is
That
Why it
point
is
E
zero?
से पास हो रहा है सर, point E
Right.
से पास हो रही है line of action.
correct. So the line of action of this 80 Newton force is passing through point E. So the perpendicular distance is 0, therefore the moment is 0. Now the moment of couple shown in figure 2 about point A.
Sir, 180 Newton meter anti-clockwise. See.
180 Newton meter anti-clockwise. Right. See, moment of the couple is always constant. Right. It is independent of the point about which it is taken, and moment of couple is equal to product of force into perpendicular distance between the two. So here 60 into 3, so it is 180 Newton meter, and the sense of rotation of this couple is anti-clockwise. Even if they ask what is the moment of this couple about point B, about point D, about point C, so it remains 180 Newton meter anti-clockwise. Okay, then moving ahead regarding some of the basic concepts like resultant of force system. What do you mean by equilibrium and what is equilibrant? So these three we are going to discuss now. Resultant of force system is defined as the net or combined effect of all the forces acting on a rigid body. If a number of forces are acting on a body and all those forces are replaced by a single force so that the effect of those forces remains same, then that single force is known as resultant force. Is it clear? Now the effect of force on the body is twofold, to produce translation as well as rotation. So the translation is because of the force and the rotation is because of the moment of force. Okay. So the combined effect, we are saying it as the resultant. Therefore, the resultant can be a force or it can be a moment. So there is a misconception that whenever you say the resultant, not necessarily it is a force, resultant force. Many times that force can be zero. When a force system is acting on a body, the combined effect of all those forces, the resultant force may be zero. That doesn't mean that the resultant of that system is zero. It may have a moment. Are you getting my point? See.
Yes, sir.
Resultant force is nothing but the net force, means algebraic sum of all the forces acting on the body. While taking the algebraic sum, we consider the forces acting towards right and upwards as positive, and the forces acting downwards and towards left are negative. Similarly, the resultant moment is nothing but the net or combined moment of all forces, that is algebraic sum of the moments of all forces. So while taking the algebraic sum, we consider anti-clockwise moments are positive and clockwise moments are negative. Now let us take one example. So there is a truck lying on the road. Now a man is trying to push the truck by applying 500 Newton force, but it is not moving. Then another person is applying a force of 300 Newton. Then the truck moves. So in order to produce motion in the truck, two persons are applying 500 Newton and 300 Newton respectively. Right. So these two forces are having some effect. Because of that, the truck is moving. Now, I am replacing these two persons with a very big person who can apply 800 Newton force, because of which the truck moves. That means we are replacing these two forces, 500 Newton and 300 Newton, with only one force, that is 800 Newton, so that it will have the same effect. Then this single force is known as resultant force. So the combined effect of F1 and F2. So the resultant force is algebraic sum. So this 500 plus 300, both are acting towards right. So it is 800. So 800 Newton is the resultant force. Now, let us consider this system. So this system is having only couples. Am I right? So F1, there are two equal, opposite, and parallel forces are acting. So you can say that the pair of forces having magnitude F1 is forming a couple. Similarly, a pair of forces having magnitude F2, they are also forming a couple. And F3, it is also forming a couple. That means three couples are acting on the body. Right? Let us say M1, M2, and M3. M1 is the couple formed by two F1 forces. And what is the sense of rotation? See here, this arrowhead is coming down, it is going up. So the sense of rotation is anti-clockwise, no?
Yes, sir.
Yes, sir. Anti-clockwise.
Anti-clockwise.
Yes, sir.
It is anti-clockwise. So M1 anti-clockwise. And see here, the sense of rotation of these couple F2, it is going upwards, it is going downwards. So it is clockwise. So the moment of M2 is clockwise. Similarly, F3, the sense is
Anti-clockwise.
anti-clockwise. So M3 anti-clockwise. So these three couples are acting on the body. Let us assume some values. M1 having say 20 Newton meter, M2 is 45, M3 is 50. Now you tell me, what is the resultant force of this system? Anybody? Resultant force of this system?
Clockwise 10 Newton meter.
No.
Sir.
Please
Zero.
listen to my question carefully.
0, sir.
0.
Yes, it is 0. I'm asking the resultant force. We know that
Okay.
the resultant force of the couple is always 0. Hence, there is no translation. No?
Yes,
So
sir.
all these couples are having the resultant force as 0. Am I right? That doesn't mean that the resultant of this system is 0. Okay, resultant force is 0, but this system can have a resultant moment. Am I right? So to find out the resultant moment, simply you have to take the algebraic sum of all these three moments. So it is plus M1, it is anti-clockwise, minus M2, M2 is clockwise, plus M3, M3 is anti-clockwise again, and putting the values, you have minus 10 Newton meter. Minus means it is clockwise. So the resultant moment of this system is 10 Newton meter clockwise. So if they ask, determine the resultant of the system shown in figure. So simply you cannot say that the resultant is 0. The resultant force is 0, but you have to find out the resultant moment also. Okay. Understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
So here the resultant
Yes, sir.
moment is 10 Newton meter clockwise, because of which the body will have clockwise rotation. Then equilibrium. So anybody, can you tell me what is equilibrium? Many times you might have studied, you might have come across this word equilibrium. So simply, what is the meaning of equilibrium?
Net force is 0.
Net force is 0.
And sir,
Okay.
it can be net moment also.
Right, that is very important. Though the net force is 0, you cannot say that the body is in equilibrium. You take this example only. Here, the net force is 0. That means this body is not in equilibrium. It is rotating. Na? That body is rotating in clockwise direction. Means body is not in equilibrium. So when the resultant of the force system is 0, you can say that the system or body is in equilibrium. When I'm saying the resultant of the force system, means the resultant can be a moment or it can be a force also. So when I'm saying the resultant of the force system is 0, it implies that the resultant force is 0 and the resultant moment is 0. Then only the system is said to be in complete static equilibrium. So when the resultant, simply the definition of equilibrium, when the resultant of the force system is 0, system is said to be in equilibrium. So when I am saying resultant is 0, it means that the resultant force is 0 as well as resultant moment is 0. Am I right? So when the resultant force is 0, there is no translation. Resultant moment is 0, there is no rotation. Then you can say that the system or the body is said to be in equilibrium. Now equilibrant.
A system which brings about an equilibrium.
Right. The system which brings the body in equilibrium. Simply you can say that when a force system is acting on the body, which is having some effect. Now you are applying some force or moment to that body so that the system is coming in equilibrium. Then whatever the force or moment which you are going to apply on the body to bring that system in equilibrium is known as equilibrant. That we are going to see in detail in the next class.